Here's another example of solving a triangle. This time we've been given the following diagram for our triangle. Once again, first thing I want to do is organize my data, make sure I have my 3 side lengths as well as my 3 angles. So with that in mind, let's take a look at some labels. I see side A is labeled, and across from it I see a 30-degree angle, letting me know that 30 degrees is referring to the angle alpha. I see across from angle beta is the side 3, so 3 is going to be B. I also see that across from the side 4 is the angle gamma, so that means that this side is referring to C. Now that we have everything labeled appropriately, let's run through our spiel. Our spiel is, do we have exactly 2 angles? And the answer in this case would be, no, we don't have 2 angles. So we move to the next question. Do we have a corresponding angle side pair? The answer is no, we do not. You'll also notice that the 3 quantities that we have here are in order side angle side. Now that's a good indicator that we are going to start by using the law of cosines. Now when using the law of cosines, if you already have an angle, go ahead and use the version that contains that angle. You'll be able to solve for the corresponding side. So law of cosines in that form states a squared is equal to b squared plus c squared minus 2bc cosine alpha. And because we're solving for a in this case, there is very, very little work to do here. It's simply going to be plug everything in and take a square root of both sides. So first we plug everything in. We get 3 squared plus 4 squared minus 2 times 3 times 4 times the cosine of alpha. Cosine of alpha, that'd be cosine of 30 degrees. Then we'll take a square root of both sides. You are under absolutely no obligation to simplify all of the things that you see under the radical. You can simply type it into the calculator as is. But if you were interested in simplifying all of this, I believe, let's see, 3 squared plus 4 squared would be 25 minus, this would be 24 times root 3 over 2. That'd be 12 square roots of 3. So, if you were interested in doing so. I'm not horribly interested in doing so, so we'll just go ahead and turn to the calculator. Square root of 3 squared plus 4 squared minus 2 times 3 times 4, cosine 30 degrees. Bam! So we are going to refer to this as, for a final answer, 2.05. But if we need to do work with it, we'll call it 2.0531. If we round too early, that can mess with the angles a bit. Now, if we recycle those questions, then we get to pose the question, do we have exactly 2 angles? And the answer is no. Do we have a corresponding angle side pair? The answer is now yes, which means that we're going to use the law of sines. Here is where you need to be cautious. Law of sines should never be used to find the largest angle. Based on what I see over here, the largest angle corresponds to the largest side. So if you're going to use the law of sines, don't use it to find gamma in this case. Use it to find beta. Law of sines can't tell an obtuse angle from an acute angle. So if we're looking for an obtuse angle and we use the law of sines, we are going to do it wrong. So the corresponding angle side pair that I have is alpha and A, so I'm going to make use of that. The angle that I want is beta. So we'll use the form that contains a beta. Plugging this in, we have the sine of 30 degrees over, we're going to hold those couple extra decimal places for our value of A. Sine of beta, beta is the thing that we're trying to find right now, and B. Now normally we would start this by cross multiplying, but we can actually save ourselves a step if we just multiply both sides by 3. If we multiply both sides by 3, this will be 3 times the sine of 30 degrees divided by 2.0531, a couple extra decimal places, and then finally applying an arc sine to both sides. Applying an arc sine to both sides, we will arrive at our answer for the angle beta. So this would be the arc sine of extra set of parentheses for the whole numerator, 3 times the sine of 30 degrees, divided by 2.0531. We get that beta is about 46.94 degrees. 46.94 degrees. We put that up top in part of our chart for beta. Then we cycle through our 3 questions one more time. 3 questions one more time. Do we have exactly 2 angles? The answer is now yes, which means that in order to find gamma, we simply need to use the fact that alpha plus beta plus gamma is going to be equal to 180 degrees, meaning that gamma is going to be equal to 180 degrees minus alpha minus beta. So 180 degrees minus 30 degrees minus 46.94 degrees. I'm pretty sure that's going to be 103.06, but I'm just going to make sure. Oops. 103.06. Now, if we had used the law of sines to try to find this angle, we would have gotten an error because of the fact that this is an obtuse angle. So I'm really glad that we didn't use the law of sines to find the biggest angle. So with that in mind, here is our final answer.